There are many factors that influence the rate of a reaction. Let's take a look at them. So when we look at these, we have each reaction has its own rate that it goes. And so those rates, though, are influenced by several different things. 4 of these things we can actually control when we run a reaction. All right, so one of them is the concentration. So molecules, again, have to collide to react. They're not going to just spontaneously react if one is over here and one is over here. They have to collide, okay? And so if I have a higher concentration, I have more particles. If I have more particles, then I'm going to increase the number of times that my molecules collide with each other. So I'm going to increase the rate there. So our reaction rate is proportional to the concentration. More reactants, more collisions, faster rate. And so when I look at this, if I have 2A and 2B, I have 4 possible collisions. If I add another A, now I have 6 possible collisions. If I add another B, then I have 9 possible collisions. And so the more particles I have, the more possible collisions, faster rate. Okay? My physical state is also something that is controllable there, that influences the reaction rate. So if I have reactants in different physical states, okay, if I have like a solid and I have a liquid, the only time I'm going to react is right at the interface where the solid and the liquid interact with each other. And so that can slow down the reaction. Or if I have large chunks, that'll slow down a reaction. If I can get smaller pieces, now I have more surface area. And so now I have more places for things to collide, interact with each other. And so I can increase the rate there. Okay, temperature. So when molecules are heated up, they are going to move around faster. Okay? And so we have to have enough energy. So there's something called the activation energy. The activation energy is the minimum amount of energy necessary to get the reaction to go. And so if a molecule collides without enough energy, it's not going to do anything. So not only do our molecules have to collide, they have to collide in the right orientation, and they have to collide with enough energy to get the reaction to go. And so at a higher temperature, everything's moving around faster. Because things are moving around faster, they're bumping into each other more frequently. So we have more collisions. All right? But also, temperature is going to affect the energy of the molecules themselves and the energy that they have when they collide. So if we raise the temperature, we're going to increase our reaction there. All right? And so if I look at this graph here, if I have my second reaction in the red there, I'm going to have more particles that have the right energy in order to react. The dividing line there, so if before this E sub A line, those are the ones that don't have enough energy to collide. And then once we get past that E sub A line, that's where I have enough energy to react. This E sub A, this is the activation energy. Okay, so again, we have to have enough energy in order to get the reaction to go, because it takes energy to break those bonds. All right? And then if I use a catalyst, so what a catalyst does is it doesn't actually get consumed in the reaction. What it does is it provides an alternate pathway for a reaction to occur. And so the presence of the catalyst there typically lowers the activation energy. And so if I don't need as much energy when I collide, more of my collisions will have enough energy for the reaction to occur. Therefore, I'm going to go faster. So you can look at this here. All right, and so in this particular reaction, the blue line without a catalyst takes a lot more energy to go than that red line with a catalyst. Sometimes a catalyst can provide a couple of alternate pathways, so you might get some sort of a transition state in between, and then you might get a secondary transition state. But again, okay, it doesn't matter if there's 1 peak or 2 on that purple line, it's still lower than the green line. Okay, same thing here. This one, the orange line is the uncatalyzed reaction. That yellow line is the catalyzed reaction. As you can see there, that's significantly lower. Okay. We've got a lot of different catalysts that are used all over the place. So like in industry, if I am making plastics or foams or things like that for a wide scale production, and I'm trying to, have a successful, productive factory that's going to turn a profit, if it takes a long time to make my products, then I'm not going to turn a very good profit. And so by using a catalyst, we can speed things up and we can make things go faster, and then we can turn out more product in a faster rate. Okay, so these are 4 things that we can influence that will speed up the rate of a reaction.